Imagine learning Kubernetes the practical way by building a real-world app step by step from scratch to full deployment in a working cluster. That's exactly what we're doing in this special series from the Cloud Bootcamp. And today we kick things off with part one of this journey, your starting point to understand how everything connects in real-world Kubernetes. In this first step, we're going to show you what Ingress is and how it fits into the e-commerce project we'll be building over the next 4 episodes. If you want to move beyond the basics and apply Kubernetes in real projects, this series is for you. And to guide you through the hands-on part, here's our tech lead, Herbert Pereira. Stick around. This is just the beginning of a journey that will transform how you see DevOps in Kubernetes.
Hello, and welcome to our special series of videos on Kubernetes in practice. The aim here will be to show you in a didactic and straightforward way the entire life cycle of a modern project in the Kubernetes ecosystem. There will be a sequence of 4 videos where you'll be able to follow step by step from the initial concepts to the final deployment of an application running on a Kubernetes cluster created with Kind and using NGINX Ingress Controller. In part 1, we'll explore the main concepts and present the overall structure of an e-commerce project that we'll be implementing together throughout the next few videos. We'll start by clearly explaining what Ingress is, a powerful Kubernetes feature capable of intelligently routing external traffic to a cluster, directing it precisely to the specific pods running inside that cluster for seamless communication and accessibility. And when we talk about a cluster, we have the pods. Within the pods, we have the containers that are running the different services, and we also have the services themselves, such as the cluster IP, which is responsible for efficiently providing internal communication between these pods. But for external communication, that's where Ingress services comes in. So for all traffic that comes externally from the internet to the cluster, the Ingress will use specific routing rules to ensure it can properly communicate with the services, which in turn interact directly with the pods. And routing rules can be created using different paths or routes. For example, I might be accessing the main route through Ingress for the home page, or I could be accessing a specific route for the product page, or even the checkout page, depending on the defined routing configuration. This can also be accomplished through subdomains. For example, here I have a domain called tcb.com, so I could easily direct user accesses to either the store part or the webmail part of the platform, depending on the specific subdomain being used. And the prerequisite we need to implement an Ingress service is to have installed the Ingress controller, and for this hands-on, we'll install it. This installation is required because it doesn't come ready by default, so we need to properly prepare the environment. Simply creating the Ingress service without also creating the Ingress controller won't really have any impact on your cluster's traffic management. They work together. You need both the Ingress service and the Ingress controller for everything to function correctly. And here we have a diagram clearly showing how the Ingress controller works. It's actually the main gateway to the Kubernetes cluster, so it's going to manage all these routing rules, intelligently directing traffic based on predefined rules. Everything that comes in, all incoming external traffic, will first pass through an Ingress controller, which in turn will deliver it to an Ingress service. We'll deploy this using its appropriate manifests, and we'll also have a deployment of the application pods. These pods already have the necessary services configured to communicate, and the communication will happen between the Ingress service and the specific service created for each pod. This is a demonstration of a typical Ingress manifest, which shows how you can efficiently route external traffic through specific paths. For example, you'll have a backend of services that communicate directly with these pods, enabling more organized and controlled access within the cluster. And moving on to a topic that often raises questions, the difference between load balancing and ingress. When we talk about load balancing, especially at layer 4, it typically distributes incoming network traffic evenly across multiple instances or pods without advanced filtering or routing. This is standard behavior when you deploy to a cloud provider that doesn't offer built-in filtering or application-level routing. However, at layer 7, the application layer, load balancers can provide more advanced features. With load balancing, all traffic is delivered to a specific service. It always routes to that one endpoint. In contrast, Ingress can deliver traffic to different services, and each service will have its own IP address, which can increase costs. It's important to note that Ingress is not a type of service in Kubernetes. Instead, it acts as an intelligent router, forwarding external traffic internally to the appropriate cluster IP services. Ingress provides advanced routing capabilities, such as path-based or subdomain-based routing, as we discussed in the previous slides. This enables flexible, efficient, and centralized management of all incoming requests within your Kubernetes cluster environment. Ingress is ideal when you want to expose multiple services using the same IP address. With a single IP, you can efficiently deliver traffic to different services, such as those responding on the store side or on the app mail side, based on the routing rules you defined. This approach simplifies access and centralizes external traffic management for your cluster. Now, let's move on and check our real-world scenario that we'll be implementing over the next few videos. Imagine you have an e-commerce application. Here, I've taken some components that are part of an e-commerce application, the main ones like the home, the product, and the checkout page. Imagine that this is implemented on a particular machine, and that machine hits a problem. It could compromise the entire solution by causing a complete outage. So in modern applications, how do you prevent this? The solution is to deploy your application into a Kubernetes cluster. This approach allows you to decouple and modularize the entire stack of application components. With this setup, you can run individual pods that are responsible for each part of the application. Additionally, you can have multiple pods for each component, ensuring redundancy and high availability across all parts of your application. When you deploy, you only have internal communication. In order to provide external communication, as we explained, you need to have an Ingress Controller, which is a specific pod. You also need to deploy an Ingress service, which will interact with the internal service that communicates with the pods. Throughout these videos, we'll be implementing the pods, nodes, ingress, services, replicas, deployments, and the Ingress Controller. And among the technologies we are going to use, we highlight Amazon EC2, the Kubernetes command line, Docker, and NGINX. The sample application was developed with HTML and CSS. We'll also use this amazing tool, which is a simple and practical solution that helps us implement and test hands-on projects like this one using essential Kubernetes components. That's the last slide for this session. This is the structure of the project. In practice, over the next few videos, we'll be implementing all of these files step by step. We'll configure the application files, including the Docker files, which contain all the instructions needed to build our images. After building these images, we'll use Kind to deploy them, handling the deployment of every part of the application. Each part will be configured with 2 replicas, so you'll have 2 pods responding for each component. We'll also create the necessary services, which enable internal communication between the pods. Finally, we'll set up Ingress, which will interact with the service and route external traffic to the appropriate pods. When the architecture is 100% implemented, from the internet, you'll access your EC2 on port 8080, which will in turn access the cluster created with Kind. We'll also have the NGINX controller, which does the intelligence part, and we'll have the rules there. So according to the path, the route, it will be delivering them to their respective services. For this to work effectively, we need to deploy both the necessary services and the individual application components, where each component will have 2 running replicas for high availability and better load distribution. That was the video part 1, where we covered the main concepts and presented the overall structure of the project. In part 2, we go on to create the structure of the project, the cluster, and the NGINX controller. In part 3, we'll configure the application files, build them according to their respective Docker files, and load these images into Kind for local Kubernetes testing. Then, in part 4, the final part, we'll create and deploy the Kubernetes manifests, the essential YAML files that define our services, and deploy the pods. Finally, we'll go live and test our application in practice, ensuring that everything works as expected from end to end. That's it. See you in part 2.
Alright, thank you so much for watching this video. And then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video, and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering multi-cloud DevOps and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.